we will be talking about topic 2.9, which is the quotient rule. So we're going to be learning how to take derivatives of quotients in this video. Let's see how we do. So most of us have already memorized our times tables. We did that when we were young in high school. We didn't memorize division tables because we could use our times tables backwards. There's no big deal. In calculus, their times and division is way easier than multiplication. And so we learned the product rule in class today, and so now we're going to be spending some time with the quotient rule. So one way to describe, when we have fractions, which is when the quotient rule comes into play. Some relationships are best described with fractions. For example, one way to write a pitcher in Major League Baseball is to use his ERA, or earned run average, which is 9 times the total number of earned runs allowed divided by innings pitched. So 9 and 9. Like if they pitch a complete game, the 9s would cancel out. If they pitch a partial game, we get that different kind of ratio there. It changes things. So let's assume this formula for Billy's speedball ERA is given by this formula, where P is the number of innings pitched. What type of function is this? All right, and so this is a quotient. It's a logarithm divided by a variable, a linear function. And so it's a little bit strange, and things would be a little different here. We did a little bit of playing with putting equations together in Math 3, but calculus puts a lot of different kinds of equations together. Let's go and find the derivative of the numerator. Shouldn't be too hard. F prime of P is equal to 9 times the derivative of ln of P, which is 1 over P. Done there. Find the derivative of the denominator. So K prime of P is equal to 1. So what do you think the derivative here might be? I'm not going to tell you what I think, because of course I know the answer and everything's a little bit different for me, but write down your best guess. So I guess E prime of P equals googly one, whatever you think. So this is your guess. Don't let me pressure you. Go ahead and pause the video and record your guess. All right, we're going to move on. So did you use your guess? So I'm going to say that I guess I better make something up. I guess 9 over P. Because, the denominator is only 1, so it probably doesn't come into play that much. So I just guess the numerator and the denominator run away. My guess. Okay. So this is my guess to evaluate the derivative if you pitched 40 innings. Okay, so a total of 40 innings over the course of whatever. Okay. So I'm going to go ahead and get my calculator open. So I've opened my calculator. I'm going to go ahead and put that equation in here. To get the fraction, I'm going to click second y equals, not second, y equals, alpha y equals, I meant. There's my fraction number 1. And so I've got 9 times that natural log of x, close parentheses, over P, or x in this case. Sorry, when I use my keyboard, this store comes in. We don't need that store. So otherwise, starting from this 9 and leaving out all the stores, that's how I type that in. Okay, so there's my equation. I'm going to go ahead and leave this field. I'm going to go ahead and click math and then the number 8. And then I'm going to do the derivative with respect to x of y1. So I'm going to do alpha, trace, and y1's right there, number 1, when x is 40. Okay, so this is the actual answer. This doesn't make any sense. Where's the money? The rate of change to the ERA is negative, so his ERA is decreasing, which is a good thing. And then I'm going to take my guess, which was 1 over P, right? Let me look back at my guess. My guess was 9 over P, excuse me. And we're going to do the same thing. So let my calculator handle that for me. And so I'm going to take 1 over 40, right? And these are pretty far apart. I know they look, I mean, they're both decimals. They're both 0.0. This one, the top one is negative though, and the bottom was positive. Those don't seem really close together. So my guess is clearly wrong. Shoot. All right. They are different. Now maybe you were really lucky and your derivative matches perfectly, and good for you, but mine was garbage. Mine didn't work. So let's go ahead and rewrite E of P as a product of two functions. So E of P is equal to 9 ln P times, whoops, P to the negative 1, right? Now let's use the product rule. We learned the product rule today. We're feeling a little more comfortable. It was pretty straightforward and easy, made sense. Derivative of the first. Anyway, let's do this. So the first times the derivative of the second. Plus the second times the derivative of the first. And then let's simplify that. So this is E prime of P. Good job, my stuff makes sense. So then I have 9 ln P over negative, I'm going to make it negative up here. This negative 1 will go in front. And then P to the negative 2 is P over P squared. And then plus 9 over P squared. Negative 1 will go down the bottom. And I'm timesing. So 1 times 9 is 1. And okay. I'm pretty close there. Okay. And so then they have the same denominator, which is nice, negative 9. Plus 9 over P squared, which is very different than what I got, right? Very different than my own derivative. But I'm feeling pretty comfortable with this. Let's go ahead and evaluate this new derivative we just received and evaluate it and see if they match. So we're going to our calculator. Now we're going to do, I think, wait. Anyway, doesn't matter. Now we're going to do the answer we just got, which was negative 9 ln. So let's do fractions. Alpha y equals fractions, number 1. Not negative 9 ln of 40, close parentheses, plus 9 over x, 40 squared. Right? So if we compare our top answer where we took the derivative with the calculator and the bottom answer, those two are identical, which makes sense. I can't remember if this was negative or not. It might have been, but anyway, doesn't matter. So clearly this one's right, this one was wrong. Well, okay, I feel better about that. So this seems correct. They match. Now, question 6 asks us to magically develop a formula for this. And if we were in class, I'd make you struggle and try all the things, but right now I'm just going to tell you. So, f prime of a quotient is equal to the function in the denominator times the derivative of the function in the numerator minus the function in the numerator times the derivative of the function in the denominator all over the denominator squared. Okay, so let's go back and look at this for just a minute. And I'm going to write my original equation down here. I had 9 ln p over p. That was my original equation. So looking at this, the denominator p times the derivative of the numerator, which is 9 over p. Okay, so the denominator times the denominator times the derivative of the numerator, which simplifies to 9. So that's right here. Okay. Then the second one, which is the numerator, times the derivative of the denominator, which is negative, which is just 1. But what did I have right here? A minus sign. Okay. So that part's right there. All over the denominator squared. So the denominator was p and p squared. So we did get that answer. So but you know, this one was not bad to rewrite as a product and just do it as a product. It wasn't that bad. It actually made a little more sense. There's a little more simplifying to it. That's what I want you to understand. And so, you know, sometimes we don't want to simplify. It's not the end of the world if we do simplify. It doesn't hurt us. It doesn't any of those things, but, you know, it is what it is. So here's the actual answer. Oh, look, it's exactly what I just wrote down. For differentiable functions f and g, and where g of x is not 0, the derivative of the quotient can be rewritten as this function. Check results with MathGate, check results by comparison with the practical, simplify the original if possible, because if you can simplify it, it's easier. And, I mean, quotient rule, joy, it is what it is, but that's the idea. Okay? All right. So I'm going to write down the way that I learned how to remember this when I was in high school. Down, d up, minus up, d down, all over down squared. So you may hear me kind of mumbling that under my breath. Here at Ramona, they use a different set of words. High, let's see, I get it wrong. Low, d high, minus high, d low, all over low squared. I like mine better. Mostly it's been in my brain for many years, and it's hard for me to switch low d high minus high d low all over low squared. I get it backwards. I don't know. So anyway. There you go. Down d up minus up d down all over down squared. Or low d high minus high d low all over low squared. Same thing. Just kind of remembering it, and this gibberish can get frustrating. All right. So if you haven't already, pause. Make sure this is in your notes fully and cleanly, and we're going to move on. All right, so we are on Check Your Understanding, which I'm going to do in another video. So I will talk to you guys soon.